Okay, so I'm going to show you guys how to do the domain of composition of functions, and I have two examples to go over with you guys. So here's the first one, and we want to get the domain of fog. So the very first thing I'm going to do, once I figure out where my pen is, there it is. Oh, God. Okay, so first thing I'm going to do is make that little machine thing that I told you guys about in class. So X is going to get pumped into G, which is the first thing. And then G gets pumped into F. So, let me get rid of this mess here. Okay, so what you want to do is you want to figure out what the domain would be for each step individually. So you see I'm not even getting the actual composition at this point. I will later, but right now I'm only fixated on finding the domain of each part individually. So when X goes into G, the problem would be, nope, hold on. The problem would be this denominator can't be 0, so we know that X cannot equal 3. So that's the first thing, is that we're not going to use any 3's. Okay. Then we want to say, well, what is G allowed to be when it pumps into F? So if we see here, the thing that's not allowed is -2. So that means that whatever comes out of G, it can't be -2. So I'm going to say that G can't be -2 because G is the thing that's pumping into F, not X. X is indirectly getting there. So since we're trying to find the domain, we want to know what X is, so we need to go back and say, well, what value would X be in order for G to become -2, which would then break F? So I go up here to G, so we have X over X minus 3, and I want to know what X has to be for that to equal -2. So I'm going to multiply both sides by X minus 3. So we have X equals -2X plus 6. This would be 3X when you add to both sides, and so X equals 2. So really, it's not -2 that you should be concerned with, it's +2, because when you plug in a +2 into G, then G spits out a -2, and then that breaks F. So now we have our domain, which would be, nope, that's ugly, okay. X is any real number as long as it's not 2 or 3. Okay, so now let's go ahead and just get the composition so that you can see it, and you'll see that nothing else pops out of it for the domain. Let me erase all of this first. Okay, so we're plugging G into F. I lost my mouse, there we go. So I'm going to write F first. So it'd be 1 over X plus 2, and the X that I'm plugging in is G, which is X over X minus 3. If you want to leave it like that, I'm okay with that, but if you want to simplify it, I'll show you how to. So we would have 1 over X minus 3, and then we need common denominators. So it'd be 2 times X minus 3 over X minus 3. And now we can combine these two fractions. So we have 1 over X plus 2X minus 6. I distributed the 2 over X minus 3. Okay, and then the last thing is that you can flip that upside down. So be X minus 3 over 3X, right? Because X plus 2X, and then minus 6. So that would be your composition. And you see that we do have something here that would break the domain. Let's look at what that would be. It's 3X minus 6 equals 0. 3X equals 6. X equals 2. And you see that we already have that value here. The 3 you don't see anywhere in here, so that's why we had to do this process. Otherwise we would have missed the 3 and we never would have known that that was going to be a problem. So now let's look at the other example. We have GOF. I'm going to do GOF first and then I'll actually do fog. So okay, so if I go up here to the top, so GOF is going to be, I'm putting f into g, so it's square root of x squared. Those are inverses, so that would just be x. And so you're thinking, okay, the domain of that would be all real numbers because it's just a line. So let's see if that's actually true. So we're taking the x, we're plugging it into f, and then we're plugging that into g. So as x is going into f, are there any restrictions? This is a polynomial, so we don't have any problem there. So that's all real numbers. When f goes into g, though, we could have a problem because this can't be negative. You can't have any f's that come out negative to go into g. But the thing is that since f is x squared, that's never going to be negative. So this is not a problem. Any number that I plug in here is still going to give me a positive number when it goes into g. Okay, so when we did the composition of functions for Goff here, we got x, which has the domain of all real numbers. And when I did it this way, I see that I still have all real numbers. So that matched up. Let's try fog now and see what we get. So we have f, and we're plugging in the g, which is this. And again, square and square root are inverses, so they cancel out, so I still have x. And so you're thinking, okay, wouldn't the domain be all real numbers again? So let's see. We're going to do x goes into g, goes into f. Remember to swap the letters depending on whether you're doing fog or Goff. So when x is going into g, you can't plug in any x's that are negative. And since we're not starting with f, there's nothing to square it and make them positive. So you could have negative numbers and you don't want them. So here, x has to be greater than or equal to 0. And then whatever numbers come out of g to go into f, those are all fine because it's x squared. You can square anything. It's a polynomial. So that's all real numbers. Okay, so you see that we do have a difference there with that in our domain. So the domain of Goff would be x such that it's any real number. But then the domain of fog would be any real number except when it's less than 0. Okay, so we have two different domains, even though both of those functions become x when you do the composition. So just because the composition looks like it would have a certain domain, don't assume that that's actually the domain. You have to go through each step and see what's going on with it. Okay.